Hello, my name is Ali Sekban. I'm a professor of computer science at Tennessee State University. In this video, I'm going to talk about the concept of inheritance in Java programming. And inheritance is one of the pillars of any object-oriented programming language. Therefore, I expect that you fully understand everything discussed in this video before you proceed with the next video. I hope you will enjoy it. Okay, so let's get started. This is for Comp 3110 Java programming class at Tennessee State University. The topic is inheritance. Let's give a little bit motivation about why we would have inheritance. Assume that you have a class called student, and student class defines what a student is. With a student has a name, a student has an ID number, a major, etc. So you already have this class. Now you're asked to define two new classes called grad student and undergrad student. Grad student and undergrad student. So the question is, would you prefer defining two brand new classes, or would you prefer using student class as a basis and build on it? Obviously, you don't want to waste what you did with the student class. Utilize it so that you can use the same concept. For example, a grad student is a student. Undergrad student is a student. A grad student has a name, ID, and major. Undergrad student has a name, ID, and major as well. So why do we repeat the same thing twice if you have a basis already defined for you? So here is the class student, which has two data members, name and ID. And name is a string, ID is an int, which has a constructor, which takes two input arguments, and it assigns the first input argument to the name, the second input argument to the ID. The reason that I use this keyword here is to distinguish this name from this name and distinguish this ID from this ID. When I say this dot name, I always refer to the name as instance variable on the top. Okay, so now in order to use inheritance, we use extends keyword. That's a keyword in Java. When I say class undergrad student extends student, I say student class will be my basis class or base class or my super class when I define undergrad student class. So what does it have? It has a data member classification. Even though it has only one data member defined within undergrad student, it inherits name and ID from its superclass called student. So undergrad student has three data members: classification, ID, and name. And then the constructor of undergrad student has name, ID, classification. It has three input arguments. The first line says super. This means the constructor of the undergrad student is the first thing will make a call to the constructor of its superclass right there. And then it is going to set this name to this name, this ID to this ID, and then this classification to this classification right there. Similarly, I have another class called grad student, which also extends student. That means student is the superclass and grad student is subclass. In C++ terms, student is the base class, grad student is derived class. Okay, what does it have? It has two more data members, thesis and advisor. Well, grad student actually have now four data members. Two of them are defined within the class, and two of them are inherited from what? Student class. Similar to undergrad student, it has a constructor which takes a string, int, string as input in this case. What does it do? It assigns, it makes a call to, again, to its superclass constructor right there first with name and ID as inputs. And then it assigns an advisor. That means this advisor is added to this advisor. In this particular example, we don't use the thesis here. So let's talk about this example. So for your convenience, I move the student class here, grad student class there, undergrad student class here. So this is our test program, this is our main method, this is our first starting point. So what do I do with this line? Grad student, GS, new, grad student, John, 511 Ali segment. I'm creating an object of grad student class. How do I know? Because I use a new keyword. So let's go ahead and do this. So GS points somewhere in the memory. And what do I have in the memory for GS? GS is type of grad student. So grad student has thesis advisor, but also name and ID. So here I will have name, I will have ID, and then I will have thesis, and I will have advisor. Okay, I will have those four things, thesis advisor, and then name and ID. That's clear. Then I'm going to make a call to the constructor of the grad student class. So that means from here, let's use blue. I'm going to make a call to this constructor right there. So this will be name. This will be ID, and this will be advisor. Okay. So then I'm going to go to the first line. It makes a call to superclass constructor. Okay. So here, this will take me to right there. And name, this will be passed right there. This will be passed right there. Okay. So, and then from this point on, that's very easy. John is name. That means this dot name is going to be John. So in other words, this will be John. Similarly, we have ID, and I pass it there. It goes there, and then this dot ID will be, so that means this is 511. Okay. And I pass advisor. I say advisor Ali segment, this dot advisor, that means this guy. Advisor will be Ali segment. Well, I didn't do anything about thesis. If you remember, instance variables are initialized to their default values unless we do any changes in the constructor. So therefore, it will be default value false. So this is what I'm going to get with that one. Similarly, I have another one, undergraduate student. That means I have, sorry, and I have undergraduate student. I allocate memory space for that. Okay. So what does undergraduate student have? Let's see. It has classification, and then it has name and ID. I'm going to go there. I will have name. I will have ID and classification. Okay. So here, okay, and as you can see, name will be Tracy there. ID will be 750, classification will be junior. And I'm going to make a call to superclass constructor with name, Tracy, ID 750. Name Tracy, ID 750. That means name is Tracy, ID 750. So this will be Tracy and 750. And similarly, classification is junior. Classification is junior. This dot classification is gonna be junior. This refers to the color of this constructor. In this case, the color of this constructor is US, us, okay, undergraduate student. Therefore, I go to the memory space where undergraduate student points to and change the classification there to junior. Okay, so that's what I have. Of course, there was one line here. It says gs.thesis is true. So what does it do? Go to the memory space where gs points to, change thesis to true. Therefore, this false will be changed to true. And then what does this say? Go to the memory space, okay, where us points to and change the name to Tamara. So this will, Tracy is going to change to Tamara. Okay. So I hope this is clear. So what are we supposed to pay attention here? Make sure that you understand a grad student is a student. Undergrad student is a student. However, a student is not a grad student, or a student is not an undergrad student. This is similar to int is a double, but double is not an int. Okay? Or byte is a short, but short is not necessarily a byte. That concept is a relationship, is an important relationship in object-oriented programming languages. A subclass object is a superclass object. Grad student is a student. An undergrad student is a student. So that's what we're going to discuss. We have here we have our superclass student, and then I have a subclass grad student. I have another subclass undergrad student. Grad student extends student, undergrad student extends student, grad student inherits from student, undergrad student inherits from student. Student is a superclass, this is a subclass, this is a subclass, or sometimes it's called base class, and this is derived class, this is a derived class. Well, how do you create classes in NetBeans, or if you use Visual Studio Code? They're pretty simple, okay? Either you can just have a single file, just like this, right here. You can have a single file. Here, test.java. And then you can have your application file test here. You can have student, grad student, undergrad student, just regular. Of course, one of them can be public, and the name must be the same as public class name. The rest are not public. This is one way, but I don't like this. I mean, you don't want to dump all of your classes in a single file. What if you use that class somewhere else? Okay, you don't have to limit yourself using your class in a single file. And what we do in NetBeans, you can go to your project and right-click, say new, add a new class file, call it student, and then do the same thing for grad student, undergrad student, grad student, student. For example, I have student, grad student, undergrad student right there. So I separate those into 4 files. One is my test file, okay? Another one is my student file. This is student, this is grad student, this is undergrad student. I made each class public, and I save them with the proper names. That's all what you need to do. Then you can go to your test class and compile. If you use Visual Studio Code, that's the same thing. Make sure that you put all of your class Java files simply in the same folder and just compile test.java. That's simple. Don't get confused. Okay, so what are the basics? Now assume that I have class A, class B, class C. If class B may be derived from class A, class C may be derived from what? Class B. In other words, class A is a superclass of class B, class B is a superclass of class C. In this case, class A is indirect superclass of class C, okay? Or class C is indirect subclass of class A. In Java, we have single level class inheritance. That means a class can extend only from another class, only a single class. In C++, a class may extend from or inherit from multiple classes, but in Java, we don't have that concept. In fact, that was one of the problematic concepts in C++, because when a class inherits from 2 classes and each one inherits from 3 classes, all of a sudden I inherit from many classes, 6 classes, and it gets unmanageable at one point. Therefore, purposefully, Java developers eliminated that multiple class inheritance. Okay, a subclass is normally larger than a superclass. Why? Well, because you have subclass, it inherits from the superclass, so it has whatever it has, and it has something else coming from the superclass. There's only one direct level of class inheritance in Java. Every object of a subclass is also an object of its superclass. A subclass object is a superclass object. A grad student is a student. An undergrad student is a student. This is called is a relationship in Java. Opposite is not true. A student is not necessarily a grad student, or a student is not necessarily an undergrad student. Okay, here's another example. I have a class car, which has some implementation. Then I have a class Honda, which extends car with some implementation. In this case, Honda is the subclass, car is the superclass. A Honda is a car. A subclass object is a superclass object. However, a car is not a Honda. Here, this is another hierarchy. I have class car, okay? I have Chevy, Honda, Toyota, let's say. And Chevy extends from car, Honda extends from car, Toyota extends from car. Sorry about this arrow, it's very ugly like that, but apparently I forgot. And then Chevy four-door extends from Chevy. So Chevy four-door is a Chevy is a car, Chevy four-door is a car. Honda is a car, Toyota is a car. A car is not Chevy, a car is not Honda, a car is not Toyota, and so on. The opposite is not true. Let's see a simple example. I have class car, which has only one data member, make, and it says a constructor. What does it do? It initializes make. So the input argument is a string, and whatever it is assigned to make. So remember, the purpose of constructors is to initialize data members anyway. So it initializes make. And it has a method called toString. Well, it doesn't take any input argument. It returns a string. What does it return? This is a plus make, whatever make is. Okay, so now I have a class Chevy, which extends car. Chevy is subclass. This is superclass. So it has two additional data members, model and year. So Chevy has model and year, and also make that comes from it is superclass. And Chevy has a constructor, which takes two input arguments, and Chevy makes a call to the superclass constructor as the first thing, and the input is gonna be Chevy, double quotes, this is a string, and then model is initialized to MD, year is initialized to Y. And this has also a method called toString. Look at them. I mean, it has a toString. This is a toString. So what does it mean? It means Chevy inherited toString method from the car class, but Chevy didn't like it. So Chevy is re-implementing its own toString method. This is called overriding. A subclass can override a superclass method if it does not like the method. Okay? So that's called overriding. Let's see what's happening here. I have class test, and I'm going to create an object called Chevy1. So I'm just going to go here, and I'm going to create this one, Chevy1. I allocate memory space for this. What do I have in this memory space? Well, I have model and year and make, right? So let's start with make, and then I have model, and then I have year. Okay, so okay, then Malibu and 2020, that means MD here, MD is Malibu, and this one is what? 2020. Okay, then I'm gonna go to the first line here, and it's gonna make a call to the superclass constructor. So it will go right there. And what is M? M is, as you see here, Chevy. So M, Chevy, that means make will be what? Chevy. So this is gonna be Chevy. Okay. Then model will be MD. MD was Malibu, and year is 2020. So this will be Malibu and 2020. Similarly, I go and create another object. I call it Chevy2. With the same logic, it will have make, Chevy, model, Corvette. I'm not gonna write everything. And then year will be 2021. Then when it says system.out.println Chevy1.toString. Okay, which toString method is gonna be called? This one or that one? Obviously this one, because we had overwritten that. And when I make a call to this toString method, right there, it's going to print, this is a year. But what do I mean by year? It says go to the memory space where Chevy1 points to and get year, which is 2020, plus space plus model. What model? Go to the memory space where Chevy1 points to, okay? Chevy1 points to, and just print that, this 2020. So when you run this program, this is what you're going to see. This is a 2020 Malibu, and this is a 2021 Corvette. Okay, let's see another example here. This time we have this. Okay, now what's the difference between this one and previous one? I removed toString method here. That means Chevy class does not have a toString method here. Everything is the same as previous example, Chevy1, Chevy2, we allocated memory space. This time when I say Chevy1.toString, which toString method is gonna be called? Since this doesn't have toString method directly, Chevy1 is a Chevy object, Chevy class doesn't have it, then it will go to the superclass. Does it have a toString method? Yes, then it will call that one. And then it will say, this is a make. What was the make? Chevy. So it's gonna say this is a Chevy. Similarly, Chevy2.toString is gonna do exactly the same thing. If you recall, go like a couple of seconds before, both Chevy1 and Chevy2 have make as Chevy, so both of them will print this is a Chevy. All right, so you should always call an appropriate superclass constructor in your subclass. Otherwise, you may have a trouble. And then I'll show you this. Superclass constructor must be the first statement in the body of the subclass or derived class constructor. If the first statement in a subclass constructor is not a call to a superclass constructor, the compiler will insert a call to the default superclass constructor for you, just like this. Well, is it good or not? Let's see. This may not be good because when it automatically puts super keyword, it will make a call to the default constructor of your superclass. What if your superclass doesn't have a default constructor? Then you are going to be in trouble. So therefore, you should insert your own constructor call. Okay. Okay, let's see this one. Okay, I have Chevy extends car. Remember, car had a constructor, one input argument constructor, right? Car has a constructor. Right here, car has a constructor. When car class has a constructor, it doesn't have a default constructor. And is Java gonna create a default constructor for car class? No. If you recall, if a class has at least one constructor, Java is not gonna go and create a default constructor for you. Therefore, this class does not have a default constructor, okay? So then here we will have a problem because Chevy constructor, assume you don't have any call to the default, you don't have any call in the Chevy constructor. Java is gonna go and put this one for, assume I don't have this call, I commented out. Then the first thing is not a call to superclass constructor, then Java is gonna do this one for you. It's gonna go and make a call to the superclass constructor for you. But which one? Default. Does car class have a default constructor? No, then you will be in trouble. It's gonna be a compile error. So therefore, it's better that you put your own call here, okay? Okay, how about this one? I have a class called Tennessee, which has a constructor, one input argument constructor. It initializes football to whatever X is. I have class Nashville, which extends Tennessee. That means Nashville is Tennessee, but Tennessee is not Nashville. This is subclass, this is superclass. Now I have my application. Now I'm creating an object of city class. Sorry, an object of Nashville class. That means a city is going to point somewhere in the memory. While I'm doing it, which constructor do I call? Default constructor for Nashville, right? Well, let's see. Since I don't have any explicit call here, first of all, Nashville, it doesn't have any default constructor. So Java is going to go and add this constructor for you, Nashville. Okay. And when Java created, it will say, okay, does Nashville have a superclass? Yes, Tennessee. Let me make a call to superclass constructor of Tennessee as well. So these statements are going to be created for you by Java. The first one is because Nashville doesn't have any default constructor and it doesn't have any constructor, it's going to create a default constructor for Nashville. And then Nashville is a superclass Tennessee. Therefore, it's going to make a call to the superclass constructor of Tennessee. But now the issue is Tennessee already has one constructor. Therefore, Java is not going to go and create a default constructor like this. So Java is not going to do that. Therefore, a call to superclass default constructor is going to give you an error. So you better be careful with this. So the error will be on line 6 because you cannot make this kind of arrangement as I explained here. Okay, superclass constructor call, super must be the first statement. For example, here, I have class car, car has a default constructor, I have Honda extends car, and Honda, first I print Honda and then make a call to superclass. No, that's an error. You have to have the first thing. Otherwise, it's gonna be what? An error. Okay, let's look at this example. And I have a class test1, which has a constructor, and that constructor prints A. I have test2 extends test1, it prints B. Similarly, test3 extends test2, prints C, the constructor. And now here in the main method, I say new test3. This may look strange to you because previously we always gave a name for every object. But I don't need to because I will never use that name. I'm just creating an object here, that's it. What Java does, it allocates memory space for an object right here. Okay, and it's gonna make a call to default constructor of test3. So that means it's gonna go right here. And then Java is gonna say, well, does this have a superclass? Yes. And what is the superclass of test3? Test2. And Java is gonna go and put super keyword for you because the first statement was not an explicit call, so it is going to make this call. That means this is gonna go and make a call to superclass constructor, which is right there. And then Java is gonna say, okay, test2, does test2 have a superclass? Yes. Is the first statement in the constructor a call to superclass constructor? No. And Java is gonna go and put this one for you here, super. That means before it goes and prints B, it's gonna make a call to what? Superclass constructor, right here. Again, it's going to Java is gonna now look, well, test1, this is the constructor, right? It doesn't have a superclass, so it's gonna go and print what? Just A. Then that means I'm done with this. That means I'm done with this constructor call. Now I can go to this line and I'm going to call B. So that means I'm done with this. That means I'm done with the superclass call, superclass constructor call, and it's going to print what? C. So on the screen, I will see A, B, and C. Okay, let's take a look at those. Okay, this is okay. Why? I have a class test5, which is a constructor. And this has another constructor. Remember this keyword, this parenthesis. Okay, I guess there is a delay in this 1 second. Okay, so I'm gonna take it from here. Let's talk about this example. In this one, I have test 5. It has a constructor. It has another constructor. If you recall, within a class, you can make a call from one constructor to another one using this keyword. So, but this keyword must be the first statement. This parenthesis should be the first statement in order to make a call to another constructor within the same class. So this is okay. However, if this is not the first statement within the constructor, that's an error. And you cannot make a call to another constructor by just class name. That's an error. Whether the first one or not the first one doesn't matter. You can only make a call to another constructor from one constructor in a class using this keyword, and it must be the first statement. Let's not forget this. Now it is time to talk about access identifiers. Now we know what a package is. We know what a subclass is. Now we can have full understanding of access identifiers. We have private, none, protected, and public. These are the access identifiers. Private means if your data member or function, if you define it private, it is accessible only within the same class. No one else can access to it. If there is no access identifier in front of a variable, for example, it is accessible from the same class and it's accessible from the other classes within the same package. If it is protected, it is accessible within the same class, accessible from the classes in the same package, and accessible from subclasses. If it is public, it's accessible from anywhere. So private is the most restrictive, public is the least restrictive. So first private, then none, then protected, and then public. That's the order of restriction or the level of restriction in identifiers. So I'm gonna talk with examples. Assume that I have class 1, class 2, they are all in the same package, and I have subclass 1. So class 1, class 2, and subclass 1 are in the same package. And subclass 1 is a subclass of class 1. However, class 2 is not a subclass of class 1. Let's look at this. There is private, is not accessible. That's for sure. None is accessible from here and from there. Why? Because they are all in the same package. Public is accessible anyway. Protected, it's also accessible because protected is the same package or subclasses. Since class 2 is in the same package, that's fine. Subclass 1 in the same package, fine. Even if subclass 1 was not in the same package, it will be still fine. Just like here, assume class 2, class 1, and subclass 1, they're all in different packages. Private is always no. Public is okay. If this is none, well, this is none means package access. Since class 2 is not in the same package as class 1, not accessible. Subclass 1, even though you may be the subclass, it doesn't mean that you're in the same package. One class might be in one package, subclass may be in another package. But if it is protected, since class 2 is not in the same package, or class 2 is not a subclass of class 1, not accessible. Subclass 1 is not in the same package as class 1. However, subclass 1 is a subclass of class 1, so this is fine. Let's be more specific, so it's gonna be better. Think about this. Test 1 is a class located in package A. Test 2 is a class located in package A. That means test 1 and test 2 are in the same package. Test 1 has a private data member and a data member with none. And test 2 has a protected data member and a public data member, okay? And here, I do this. I create an object of test 1 class, and I make a call to A. So you tell me, is this okay? First, I created an instance of test 1, and I'm making a call to A. A is private. A private data member is not available to any other classes. It's only available within test 1. Therefore, this will be immediately an error. So you cannot do that. How about B? Well, B has none. None means package access. Since test 1 and test 2 are in the same package, this will be fine. Okay? Now, obviously test 3 is not in the same package as test 2. Why? Because I import package A. So now test 3 extends test 2. This is subclass, this is superclass. Test 2 is located in package A, test 3 is not located in package A. So now I'm making a call. Pay attention, I don't need to create any object because anything that belongs to test 2 also belongs to what? Test 3. Now my question is this, can I just go and say C is equal to 30? C is protected. Protected means either package access or subclasses. I know test 3 and test 2 are not in the same package, but test 3 is a subclass of test 2. Therefore, this will be fine. And D is protected, D is public, and that will be obviously fine, okay? Now, let's look at this. This time test 3 extends test 1. And obviously test 3 and test 1 are not in the same package. And now I say B is equal to 300. Is that possible? B is here none, right? None means package access. Since test 3 and test 1 are not in the same package, this will not be okay. And then A is 400, A is private, I cannot access to it. So this will be an error as well. Here's another example. Let's see. I have class car, I have non-private protected public, I have truck, okay, and I create an instance of car class. Obviously, they are not in the same package. They have no subclass, superclass relationship, nothing. So I create an object of car class, and now I say X. X is none. None means what? Package access, right? Since truck and car are not in the same package, this will be an error. How about Y? Y is private. That's obviously an error, okay? Now, Z. Z is protected. Z is protected. Oops. Protected means either in the same package or subclasses. Well, car and truck are not in the same package. There is no subclass, superclass relationship either. So this will be what? An error as well. Then string, that's public. So public should be fine, right? This is an error. Pay attention. I can call S only with a car, and I forgot that. If I had a car.S, that would be okay. But when I just say S, well, what is S? Where is it defined? It's not defined there. This doesn't have a superclass, so that's not gonna make any sense, okay? Here, now I have car package. That means Chevy and Toyota are in the same package, and Chevy extends car, Toyota extends car, okay? However, Chevy and car are not in the same package. It's somewhere here. And this says int, none, protected, private, and now I have this one, Chevy, X5. X, is it defined in Chevy class? No. Then I'm gonna go to car class. Do I have an X? Yes. It has no access identifier. No access identifier means what? The package access. Since Chevy and car are not in the same package, obviously this will be what? An error. Then, sorry, not there. This will be right here, an error. And then Y12, Y is private, that's not accessible. And then Z is protected. Protected means either subclass, either it's the same package or subclasses. Chevy and car are not in the same package. However, Chevy is a subclass, so this will be fine. Now, S, hello, this is public, and S is not defined in Chevy, but defined in car. And obviously, I don't have this issue here because that's my superclass. Then, therefore, this will be fine. Then let's look at this. Toyota, Chevy, they are in the same package, right? So I created a Chevy object and I say a Chevy.A. A is none. None means what? Package access. Are Toyota and Chevy in the same package? Yes. Therefore, this will be fine. And B is protected. Protected is either in the same package or subclasses. Well, they don't have subclass, superclass relationship, even though both extends from car. That doesn't mean they have subclass, superclass relationship. Chevy doesn't extend from car, or Toyota doesn't extend from Chevy. So, but since it is protected, and since they are in the same package, this will be fine. And C is private. That's obviously an error. I hope you understand private, public, protected, and none concepts. It's very easy. None means package access. Protected means either the same package or subclasses. Private is only accessible within the same class. Public is accessible from anywhere. Okay. Let's see. Okay. Let's look at this. Okay. Car class has a method called toString. Chevy class is a method called toString. As I told you, Chevy class does not like the original implementation of toString class, and it defines its own implementation of toString class. This is called method overriding. A subclass overrides a superclass method. Don't get confused with overriding and overloading. If you recall, overloading was within a class, you can define multiple methods with the same name as long as they have different signatures. Overloading is within a single class having multiple methods with the same name. However, overriding is totally different. Overriding is redefining a superclass method in the subclass. And for overloading, there was a rule. They must have different signatures. And for overriding, we also have rules. You can define a method in a subclass that has the same signature as the method in the superclass. This time, when you override, they will have the same signature. Additionally, the access identifier in the subclass will be either the same as in the superclass or less restrictive. It cannot be more restrictive. Let's see. And that means, for example, if you have a method which is public in the superclass, in any subclass, that method must be public because there is nothing more less restrictive than public. Let's talk with examples. We'll understand better. Here, class car. Here, class Honda. This is toString method. Honda does not override toString methods. So Honda does not override it. However, Chevy overrides. Look at this. What is the signature of toString method? If you recall, signature was what? The name and underscore input arguments. There is none there. What is the signature here? toString underscore. There is no input arguments. And this is public. This is public, the same access identifier. So this is perfectly okay. So what happens when we go and do this? Create a car. Now I'm going to go ahead and create an object called a car. A car is a car object. That means it's going to have only one data member, which is called what? Make. And which constructor do I use? One input argument constructor. Then that means this is BMW, M will be BMW, make will be BMW. So this is, oops, sorry. This will be BMW. Then I'm gonna go and create an object called a Chevy. A Chevy. Sorry about the handwriting. And then a Chevy has model, year, and make. So I'm gonna have make, model, and year. Okay, which constructor I call? Two input argument constructor. Malibu is MD, 2020 is Y. And then I'm gonna go to the first line first, make a call to superclass constructor. Right there, Chevy M, that means M is Chevy, and I'm gonna assign it to make. So this is Chevy. Once I'm done with this, I'm gonna go here. I'm gonna assign M to the model. MD was Malibu, and Y was 2020. So this will be Malibu and 2020. Similarly, now I have a Honda. Let's go ahead and create a Honda object. We have the memory space for that. In this memory space, what am I going to have? Model, year, and make. So let's start with make, model, and year. Okay, so let's see. MD is pilot, Y is 2021. So I will go to the first line. Go to the superclass constructor that takes a string as input. So M will be what? Honda. That means make will be Honda. So this is Honda. And similarly, MD is pilot, Y is 2021. This will be pilot and 2021. Then I'm going to go and make a call to toString method via a car object. Well, I'm obviously going to make a call to this. It's going to say this is a make. Make. Go to the memory space where a car points to and get make, which is BMW. So it's going to say this is a BMW. And then I will go to a Chevy toString. Since Chevy class has a toString method, I'm going to go and make a call to this. This is a year space model. What is year? What is model? Go to the memory space. A Chevy points to get year, which is 2020, and get model, which is Malibu. And then the last one, Honda toString. Well, Honda class doesn't have a toString method, but my superclass has it. I'll go and make a call to this. This is a make. What is make? Go to the memory space where a Honda points to, get make, which is Honda. This is a Honda. Well, add override is just annotation, okay, that informs the compiler that the element is meant to overwrite. So it is not required, it is not something that you should worry about it, but add override, for example, when you use NetBeans, you can put add override sign in front of a method, on top of a method, so that tells Java that, hey, you are trying to override a superclass method. Then Java is going to warn you if the signature is different or the access identifier is not matching or not least restrictive. Java is going to give you a warning. If you don't have override, Java is not going to give you any warning because Java will not know that you are trying to override a method. Here is an example. Okay. Let's see. Class Chevy. Now I have two string methods. Well, class, if you recall, oops, too much. Okay, if you look here, toString method of car class, toString method of the car class, right there, doesn't take any input argument, right? But when I overwrite here, I have toString method, which takes an integer as input. Actually, I meant to overwrite toString method, but I made a mistake. I didn't keep the same signature. Java, in this case, will consider that you are trying to create a brand new method called toString. You are not intending to overwrite the class, toString method of the car class. So Java doesn't know this. However, if you put override at override right here, that means Java will know that, hey, you have a toString method, your superclass has a toString method. That means you are trying to overwrite that method. And at this point, Java is going to give you an error because it's going to say that this is not a proper overwriting. But here, it will not give you an error because it will not know that you are trying to overwrite. Your intention is to overwrite to string method. I hope you understand. This is just a convenience. If you put that one, it helps. Okay, this is the mother of all classes. It is very bad name, actually, and calling a class object. I don't know what was the logic there, but I'm puzzled with it. There's a class called object, which is the mother of all classes. It is a superclass of all other classes. a variable of type object can hold a reference to any object, whether it's an instance of a class or an array. I will explain what it is. So since object class is a superclass of all classes, any object that you create inherits from the object class, either directly or indirectly. What does that mean? First of all, object class is located in what package? Java.lang package. That means object class, you can just use it. It has 11 methods. Look here, actually this method should be familiar to you. ToString method, takes no input argument and returns a string. You see that? So, and this is a very, so that class has, object class has that one. In addition to that, there are other methods. We are going to talk about finalize when we talk about garbage collection. We'll talk about wait, notify all when we talk about multi-threaded programming, and hash code we are going to talk about when we have collections. And it has also one method called equals, which takes an object as input, returns true or false. Okay. So ToString method is a method of object class. So that means every class can override it. Whenever you need the string representation of a class, actually a string representation of an object, Java is going to make a call to ToString method. What happens if the class does not have an overridden ToString method? Let's see with, well, this is not that example, but we'll come back to that, I suppose. Okay, let's look at this. Car. It has a method called isLikeARock. It used to be in the Chevy commercials, if some of you may remember. So this isLikeARock is a method that takes an int and returns Boolean, and access identifier is what? Protected. I have BMW extends car. So BMW is the subclass, car is the superclass, and the question is which three can be placed there. So let's see. isLikeARock. So basically I'm trying to override this. Is this a proper overriding of this method? The same name, the same input arguments. So the signature of this is isLikeARock int, isLikeARock int, right? So that's the same. Return types are the same. This is protected, this is public. Well, public is less restrictive than protected, so I am fine, okay? The same name, the same signature, the same return type, and also less restrictive. How about this one? Same name, right? The same name, the same input arguments, types, the same return type, the same access identifier. That's fine. But here, the same name, the same input argument types, the same return type, but here I have what? None. So none versus protected. Which one is less restrictive? None is more restrictive. When you override, you cannot have more restrictive. So this will be an error. You cannot have more restrictive. Okay? Okay, now let's look at this. isLikeARock, int long. The same name, different signatures. Even though there is no access identifier here, pay attention. This is not overriding. This is not overriding. This is overloading. Because what I'm doing here in BMW, I define a method isLikeARock with int long. That means the signature of this guy is LikeARock underscore int underscore long. The signature of this guy is LikeARock underscore int underscore int. Well, they have different signature. That means I'm not overriding. And BMW has a method called isLikeARock with this signature, and BMW has a method called isLikeARock with this signature, because BMW extends from car. The methods of car class also belongs to BMW. So this does not mean anything. It doesn't have to be less restrictive because I'm not overriding. Well, there is something that you should also understand. You cannot, this is a non-static method right there. when you override, you cannot override as static method. This is something I'm just put there as extra information. You don't have to fully understand that. But when you override a non-static method, it needs to be non-static. You cannot override a non-static method as static. Okay. However, if your method is static in the car class, this is perfectly okay. Okay. Okay, now let's see, is like a rock, the same signature, the same return type, the same access identifier, static, static, okay? Here, let's see, and this is static, this is non-static, you cannot override, just the same as like non-static cannot be override with static, static cannot be override with non-static. Okay, how about this one? The same name, the same signature, okay, and they must have the same return type as well. For method overloading, if you remember, the return type has no importance. But when you method overriding, unless they have the same return type, you cannot do method overriding. Because the reason is very simple. So what happens here is, well, Java will say, okay, I have a method just like this, but I have another method just like this coming from my superclass. I have two methods with the same signatures, but they have different return types. So Java is going to get confused which method to call, which method needs to be called. Let's see. This is as if, what does it look like? And I'm saying, yeah, that means you are having overloaded methods, but you're not overriding, because those two, unless those two are the same, that's not, yeah, that's not overriding. I hope I'm not getting confused here with, it's simple, when you override, they should have the same return type. All right, let's look at this example. Class 1, this is class test extends class 1, this is which overriding methods can be successfully placed. So how can, which ones are correct? Let's see if the first one is correct. The same name, the same, but return types are different. Second one, the same name, the same input argument, the same return type. Public is more restrictive, less restrictive, so I'm fine. The same name, different signatures. So that's not method overriding, okay? Even though that's not an error, it's not a method overriding because they must have the same signature. How about this one? The same name, the same input argument, the same return time, the same access identifier. You can make it final in the overridden class. That's fine. A final method means that method cannot be further overridden. If there's another class that extends from test, that one cannot override a method. And 5 is not correct. Why? Because the return types are not the same. Okay, so I'll talk about final methods anyway. So let's talk about this here. What does this say? Okay. Oh, okay. So let's be careful with this. Public class food. This has a constructor, right? This is a constructor. Is Java gonna go and put a default constructor for me, just like this? Food. Java is not gonna do that. Why? Because I already have a constructor. Now here I have orange extends food, and orange doesn't have any constructor. So Java is gonna go and create what? Orange, like this. Since orange has a superclass constructor, Java is gonna further go and put what? Super, like this. The issue is that when I make a call to superclass constructor, which is the default constructor of superclass, I don't have this, and it will be a compiler. Okay. Okay. But if you had this default constructor right there, for example, something like this, it will be okay. Okay. This is a little tricky maybe. We have test1, sorry. We have test1 class, which has a data member, a constructor. Test2 extends test1, which has a constructor, and the constructor makes a call to the default class constructor. So now here, let's take a look at this. I create obj, okay, and I use, okay, obj will point to a memory space. And which constructor do I use? The constructor takes one input argument. So this 99 will be right there. And this will be 99, right? Okay. And it will go to superclass constructor. Okay. And this is 99. And this is 99. This is 99. And that means this guy will have x 99. So it's going to print 99. How about this one? Let's see the difference between them. What is the difference between them? Okay. Oh, this time, okay, this is private. You see that? This is private. Well, if you make your superclass data member private, that's only accessible within test1. So when you try to make a change via subclass, you're going to get a problem there. Okay, so let's see. Is there a compile error here and why? I guess this is class 1. It has a method a method. This is class 2. It says a method a method. First, is this proper overriding? The same name, the same input arguments, but different return types. Once you have different return types, that's going to be an issue. Okay. It's going to be compiler. Casting objects. This is really important. You can cast an object to another class type. And if the object and the new class types are in the same hierarchy, of course. For example, you can have a cast between Honda and a car, or you can have a cast between dog and animal, but you cannot have a cast between a dog and a car, for example. Okay. So for example, we have this Chevy 4-door is a subclass of Chevy. Chevy is a subclass of car. Car is a subclass of object. So you can have a casting in this direction, or you can have casting in this direction or in this direction. You cannot have cast between these two or between these two. Okay. So I'm going to talk about casting objects up. So this is very similar to the idea. Byte is a short. Short is an int. Int is a long. Long is a float. Float is a double. Remember that? So for example, if I have int, if I assign I to f, that's perfectly okay, because an int is float. Java will implicitly cast int up to float. So, and I know float is a double, so there's an implicit casting up float to double. B is 20 bytes, and then SB byte is converted to short. This is perfectly okay. So casting objects up is implicit in this case. Similarly, I know a Chevy is a car, a Honda is a car, a grad student is a student, an undergrad student is a student. Similar to that. Therefore, assume that I have a car class, I have a Chevy object, I have a car object, a Chevy object, and a Honda object. Look here, int is a float. A Chevy is a car. I can assign a Chevy to a car. A Honda is a car. I can assign a Honda to a car. Similar to I can assign a bike to short. This is implicit casting up Chevy to car, implicit casting up Honda to car. I hope this makes sense because we know a Chevy is a car. I can assign a Chevy to a car, a Honda to a car. This is called casting objects up. Why? Here, Chevy is cast up. Okay, Honda is cast, we are casting Honda up to car. Okay, so here, for example, we have student, grad student, undergrad student. I can say student is equal to grad student. This is assignment. That means I'm assigning a grad student to student. I know that a grad student is a student. I can do that. Undergrad student to student. This is also perfectly okay. All right. Why? I mean, a grad student is a student. And this one is also okay. Look, I say student GS is equal to new grad student. What do I do here? I first create a graduate student object. This is a grad student object. I first create a grad student object and I assign it to what? To a student object. This is perfect okay. Similarly, I first create an undergrad student object and assign it to what? A student object. This is called casting up. And this is done implicitly for you. You don't have to worry about it. Just like an int is a float. A grad student is a student. An undergrad student is a student. A Chevy is a Honda. Sorry, a Chevy is a car. A Honda is a car. Okay. But the opposite is tricky. Casting objects down. You know that byte is not a short. Short is not an int. Int is not a long. Long is not a float. Float is not a double. If you recall, for example, I have float f. This is floating point number. If I try to assign it to an int, I get an error. In this case, Java says, sorry, you cannot do it. A float is not an int. But I can force Java to do it. If you recall, I can go and put parentheses int. This tells Java, hey, I'm aware that that's not an int. I still want you to treat it as int. I know I may lose something. In this case, what am I going to lose? I'm going to lose the fractional points, right? So I take that risk. I will lose it, and I take that risk. Similarly, you have a double. You try to assign double to float. Java says, sorry, you cannot do it. But you can say, I'm going to take the risk. I'm going to do this. When you take the risk, that means there is a possibility that you may be losing something. For example, if D is not 34 point, if it's 34.6, you're not losing anything. But if it is not 34.6, but if it's an extremely big number, which is not in the range of float, then it's going to come up with a number based on an algorithm, and then it's something that you may not like. So, okay. Similarly, a car is not a Honda, a car is not a Chevy. So if I have a car, a Chevy, a Honda, if I assign a car to a Chevy or a car to a Honda, Java will complain. Similar to, I cannot assign a float to an int or a double to float. Say, sorry, you cannot do it. I'm not going to allow you to do that. But what do? You say, okay, Java, I'm aware, but I'm going to take a risk. I want you to assign a car to a Chevy, and I'm going to put right here. Similar to what I did, I said, for example, float, right, F, and I said, I want this D to act as what? A float, okay? So I know that's not it, but I want it to act as float. Similarly, I know a car is not Chevy, but I want you to do it. This is called explicit casting. Casting up is implicit. You don't have to do anything. You can say a car is equal to a Chevy. No problem. But a Chevy is equal to a car. You cannot. You have to explicitly do it. Okay? Otherwise, Java will complain. Similarly, let's look at this. I have student, grad student, undergrad student. Well, an undergrad student is not a student. A grad student is not a student. Therefore, I cannot assign student to grad, student to undergrad. Java will not allow me to do it. But again, I say Java, I know they are not, I take the risk. I want you to treat student as a grad student. I want you to treat student as an undergrad student. I may be losing something, I take the risk. This is called explicit casting down. Why casting down? Student was on the top, grad student was on the bottom, on below, so it's going down, right? So this is casting down. A student is not a grad student, a student is not an undergrad student. Well, if we force a double to act as an int, we lose something. For example, here, this is double D 34.5. I will say, okay, Java, I know double is not an int, but I want you to treat as an int. Then if I print double, it prints 34.5, but if I print I, it prints 34. I lost something. And I knew I might be losing something. Similarly, what do we lose when we cast objects down? Okay, let's see with an example. Here, I have class car, constructor to string, class Chevy, constructor, and I'm overriding to string method here. I put this explicitly so that Java makes sure that I'm overriding. And then I have a method called is like a rock. Is like a rock returns true. Okay, very dummy method. Is like a rock. It was from Chevy commercial. So is like a rock method. If whenever I call is like a rock method via a Chevy object, it's going to return true. Okay, so now first I create a car with BMW. Okay, and let's see, sorry. Okay, I create a car, and then if I create a car here, a car, it's going to have make BMW. Then I create another car, actually a Chevy. If you recall, this will have make Chevy. We already did this before. And then we will have model Malibu, and year will be 2020, right? Then I say a Chevy is like a rock. Okay, is like a rock will return true because it's like a rock method. Whenever I call it via a Chevy object, I call it with a Chevy object, is like a rock method is going to return true. And this compiles and runs fine. How about here? So now let's look at this. I say a car. I created a car right there. I have a Chevy. Now I say, I say a car is equal to a Chevy. What does that mean? A Chevy used to point to this memory space, right? That means a Chevy will not point this memory space anymore. It will point to this memory space, wherever a car is pointing to. You get it? So, and then when I try to make a call to is like a rock, there's no compiler because syntax is correct. Chevy class has a method called is like a rock. But when I try to run it, well, a Chevy in reality is pointing to a memory space where a car points to. And therefore, there's no way for it to call what? Is like a rock method. So you're going to lose that one. Even though you thought you could call, you're not going to be able to what? Call that one. I hope you understand this. Okay, so here is what's happening. We have a car make BMW. Then we have a Chevy, okay. Chevy class. Why is this BMW? Let's see sorry. Let's go back a little bit. Maybe it's too much to go at this point. So So here, make, model, there's a mistake here. Okay, there's a mistake here. This is supposed to be Chevy, Malibu, and 2020. Sorry about that. Just this is Chevy, this is Malibu, this is 2020. That means a Chevy really points to a Chevy object in memory. So there's no problem here. It's like a rock will work. However, here we have a car. Again, there's a little mistake here. And here, a Chevy does not point this memory space, but it points where? Right here. Now, when I make a call to is like a rock, a Chevy really points to a car class object in memory. So that's the issue, okay? Okay, here is another example. Let's see, I have a class 1. What will be the output when the following code runs? That's the question, okay? I have class 1, I have method 1, and I am overriding method 1 here, the same input argument, the same return type, the same access identifier. I have method 2, okay? So here, I create an object of test class, and I make a call to obj I. All right, so let's go ahead and draw this. I have an object called obj, and the type of this object is test class. That means it has an I right there, okay? And I is 4. Then I make a call to method 1. Method 1 of what class? Test, which is right there, 4, and method in test, and then another method in test. Nothing interesting here, okay? But pay attention, I did create it just like that. What about if I create the object like this? A subclass object, sorry, the subclass object first. What if I create a subclass object and assign it to superclass object? Now what's gonna happen? What is it going to print? Is the tricky one. Here, that's what I do. Okay, this is something that you may not see everywhere, okay? So I create obj, okay? What is the type of obj? Class 1. Bam, I will have I is equal to 2, okay? Therefore, when I print I, it's right there. Then I say obj that method 1. Is it going to be this method 1? Because obj1 points somewhere in the memory. However, when I created it, I assigned a test object to obj. In fact, obj, for data members, we use data members of class 1, but for method calls, we are going to make a call to the methods of what? Subclass. In this case, it's going to make a call to this one. So this is very interesting. So it is not 4, it is 2, but it's going to make a call to this method, method 1. And you cannot make a call to method 2. That will be compile error. Why? Because method 2, I make a call via obj. Obj is class 1, and class 1 doesn't have method 2. Compile time error. Remember, at compile time, Java doesn't know which points were in the memory. All Java cares about the syntax, and syntax is not correct here. Why? Method 2, I'm calling via obj. Obj is a class 1 object, class 1 reference actually. Class 1 doesn't have method 2, then that will be a problem. Okay, that's what I explained here. This is a compile error. This is interesting. So let's look at this. I have a class called super. Look, this S is capital. Remember, Java is case sensitive. Lowercase super is different than this uppercase super. This is just a name for a class, super. And this is uppercase, this is the constructor, this is a method. And then I have test, which extends superclass. It says an I, this has an I, and this overrides this method, hello. This is the constructor. Constructor change this I to 40, and it also makes a call to superclass. Look, super constructor call should be the first statement I said, but this is different. I say this dot I, that refers to I of test class. When I say super dot I, it refers to I of the superclass. So now I create a superclass object. I create a subclass object here. Subclass, because test is subclass of superclass. I create an object of subclass and assign it to what? Superclass. So this is a subclass object, and I assign it to a superclass reference. And I say b.I, well, it's gonna make a call. It's going to b.I is gonna go, let's go to this, b, let's go to this constructor right here. Okay, I'm gonna go to this constructor, and this dot I will be 40. So this dot I, okay, b points to a memory space in which I have I, okay, and this dot I, this will be 40, and super I, this will be 10. As I told you, b dot I, you're gonna look for the type here, which is gonna be 10. So it's gonna print 10. But when you make a call to hello, well, which hello? Is it the hello of test, hello of super? It's gonna be hello of test, which is here. It's going to print hello right there. Okay, so what does it say? When calling methods, you need to consider actual objects. When calling variables, you need to consider reference. That's what it's trying to say. Okay, let's look at this example here. This is, we have test1, which has two methods. We have test2. We overwrite this method, only that method. And then I have x, and then I have here, I create an object of test1, and I create an object of test2, okay? Now, when I say o1.method1, let's see, o1, in fact, o1 points o1 points somewhere in the memory in which we have test1 object, and o2 points somewhere in the memory we have test2 object. There are no confusion. There is no confusion. So method 1, when I do method 1, it's gonna go and make a call to what? Let's see, method 101, test1. Let's see. Test1. Let's look at this for a second. Okay, so O1 method 1 is gonna go from here to here. It's gonna return X, and X is test1. Therefore, you will see test1 right there. And then method 2 is gonna go to all the way here, and you're gonna return, it's gonna return hello. You will see hello. And here, O2.method1. Method O2 is test2 object. Test2 doesn't have method 1, but it is superclass as a method 1. So it's gonna go up and make a call to method 1 again, and you will see test1 again. Then method 2, well, O2 is test2 object, and test2 already has overridden method 2, so it's gonna make a call to what? This method, which is gonna say ha. Okay. All right, so these two are okay. Why? We have class 1, which has a constructor. We have class 2, and class 2 has a constructor, and the first keyword that I use is super. What does that mean? It's gonna go and make a call to superclass constructor. I have another constructor. Again, the first keyword is what? Super. This is perfectly okay. And here, again, the first one is super, but here, the first one is not super, but I say this. This is fine because this is gonna make a call to what? This constructor, and this constructor is gonna make a call to superclass constructor. You cannot have both this and super. You will have only one of them because each one must be the first statement. If you have super, it must be the first statement. If you have this, it must be the first statement. Therefore, you cannot have both. it contradicts with the condition that it must be the first statement. Well, I hope this is not too much, but this is important that you fully understand all those important concepts in Java, especially inheritance. The next step for us will be talking about other kind of classes like abstract classes, interfaces. We'll talk about polymorphism and inner classes. So I suggest that you fully understand what has been discussed in this video. Thank you, and I'll see you in the next